Welcome and hello. This is a video lesson in MODSIM, and in this lesson we're going to be talking about a few topics related to hydropower, which are pumped storage, outlets, and hydraulic capacity within a reservoir. All right, so let's go ahead and get started. What I have on the screen here is my MODSIM. It is a very simple schematic with inflow node flowing down to a reservoir, Res1, which flows down to a demand D1, and then finally to our network sink. Let's first talk about pump storage. Pump storage refers to when water is pumped from the downstream end of a reservoir back up into the reservoir to regenerate power a second time. Pump storage projects are indirectly modeled in MODSIM by increasing the generation hours per period beyond the total actual hours in that period. So the topics that we're talking about in this lecture will refer to high head reservoirs, which were covered in lesson 18, as opposed to run-of-the-river reservoirs covered in lesson 19. So with regard to pump storage, sometimes reservoirs pump water at lower demand periods where the cost of electricity is lower, and then run it through the power plant when the demand is higher, and hence the cost of electricity is higher. And the way that is modeled in MODSIM is if you open up the properties dialog box for the reservoir and then click on the power tab. Let's go ahead and just add in a 100 megawatts max power generation. And then with peak generation checked on, you click on this gen hours. We now have the number of hours in the month, we'll say. Actually, let's go ahead and change this. So the default here is hours per month, 744. That's the total number of hours in a 31-day month. But just to make it a little easier, let's just say hours per day. So the max would be 24 hours in a day. However, if we have pumped storage, we're actually going to be generating a little bit more power than we would without a pumped storage system. So you wouldn't make it 100 or something huge. It would just be a little bit larger to effectively increase the load factor for that hydroelectric plant. So instead of 24, if we changed it to, say, 28, then 28 divided by 24 would be the effective load factor for that hydropower plant, which would equate to 1.1666. Now, in MODSIM, only models water flowing downstream. It doesn't actually do a mass balance where it moves water back upstream. There's no pump icon over here in the node palette. So water is always going to continue to flow in the downstream direction. But if there is some sort of pump storage project that needs to be modeled, and then the hydropower values need to be accommodated, and we do that by increasing the load factor right here. MODSIM allows the load factor to exceed 1 to simulate the extra on-peak energy delivered by pump storage systems. And this is used for models that are focused on power generation. So that's how that works right there. I'm going to click Apply, OK, and then Apply and OK. The next topic is reservoir outlets, and we're going to see the storage right extension used in this discussion. So as you see in the model, we have inflow flowing to the reservoir. It discharges through a hydroelectric power plant, we'll say, that goes downstream to demand D1. But say, for instance, we have another demand over here, and we call that D2. Let me just sketch a link from the reservoir to D2. If a reservoir has a power plant, MODSIM assumes that by default, all the flow released from that reservoir flows through the power plant. But that may not always be true. For instance, we could have a bypass link to another node, like a demand node or a non-storage node, where the water flowing from that reservoir doesn't actually make it through the power plant. It could just be through some auxiliary outlet that doesn't have a power plant related to it, or it could be through a pipeline, a bypass to another part of the network altogether. Now, of course, the flow from D2 could, rejoin up to the same flow path or somewhere else, or it could just terminate right there. But regardless, the point is not all the flow from reservoir 1 would necessarily generate power. So to model this in MODSIM, you're going to go up to the MODSIM extensions. And before that, I'm going to actually show the before and after on the reservoir properties box. So let's just open that up real quick. Here on the general tab, notice what we have. We have reservoir information, priority, and then no form fields below the priority section. So I'm just going to click OK. Now let's go up to MODSIM extensions. Click on this first extension here for storage rights extension. Apply. OK. Now let's open up that reservoir properties box once again. And if I click on the General tab, now below Priority, we have some form fields here for storage rights information. Reservoir system number, reservoir bypass link, reservoir outflow link. We're not going to use the system number, but what I want to do is identify which links are the main reservoir link. That would be the link that is generating hydropower. That would be from Res 1 to D1. So I'll go ahead and make that selection. And then the bypass link, this would be the link that does not generate power. So I will set that Res 1 to D2. All right, so that's how that assignment is made. If you don't make this assignment, then MODSIM will over-calculate the amount of power generated from the Reservoir 1 hydroelectric plant. The last topic in this lesson is the hydraulic capacity of the reservoir. So let me go ahead and click Apply, click OK. What I'm going to do is actually toggle off that extension real quick so we can do another before and after comparison. The amount of power generated from the hydroelectric plant is shown here. Power equals K times Q times H times E. This is equation 10, which is on page 42 of the user's manual. This Q term here refers to the amount of flow or release through the hydroelectric power plant at the reservoir. This I is referring to reservoir I. The time is related to time period T. And then the flow itself is capped by just the physical limitations of the reservoir and gravity and everything else. So the reservoir operators cannot release all of the water from the reservoir in an instant, right? There is a maximum capacity, and that's based on just the pipe works and the geometry and the outlet structures in the reservoir. So there is a maximum value here, and that maximum value is defined in the hydraulic capacity column, which is in a table in the reservoir properties. So let me go ahead and open up the ACE hydraulic capacity tab. You're probably wondering what hydraulic capacity has to do when all we see is area, capacity, and elevation. So this is what we're seeing without that storage rights extension enabled. So I'm going to click Apply, OK. So let's enable that extension once again, MODSIM extensions. Check on the storage right extension, Apply, OK. Right click on the reservoir properties. And if I click on ACE hydraulic targets, now we have this new column here for the hydraulic capacity, and we have a new units up here. So acre feet per month is the default units. And then as the water surface increases from the invert of the reservoir up 50 feet, 100 feet, 150 feet, and so on, the hydraulic capacity or the amount of flow that can physically be released would be listed in this column right here. So over in Excel, I copied some data. I'm going to just paste that column of values right here. So this is just numbers I made up, but we're going to start at 0. And then as the water surface increases, there's additional release capacity within the reservoir. And these values right here will serve as the upper bound in that equation for generating power. This right here. These Q values have a maximum of the value which is in this column, and the values the reservoir would use for its maximum hydraulic capacity are based on the storage, which is in this column here. So for every time period, T, there will be an average storage, or well, it's called capacity here. This is really just the volume of water in the reservoir. So based on interpolation and iteration, the average elevation during that time period can be determined, and then hence the average hydraulic capacity. That's how the maximum Q in that power equation is determined. Adding a maximum hydraulic capacity constraint in the reservoir is modeled like this behind the scenes. In MODSIM, without a hydraulic capacity or a max Q, a max release flow rate, it would be this upper figure right here. But when you impose a maximum flow restriction based on the hydraulic capacity, an imaginary node behind the scenes is added to the network, which has an imaginary link with the maximum capacity of that link equal to the hydraulic capacity of the reservoir during that time step. All right. So that's it for this lesson. What we talked about were some hydroelectric power topics within MODSIM, specifically ones that relate to high head reservoirs, which were the pumped storage, different outlets, as well as hydraulic capacity, which were possible by enabling the storage rights extension.